Welcome to the 2026 Southeast Michigan Fisheries Workshop. I'm Angela Scapini. I am an extension educator with Michigan Sea Grant and Michigan State University Extension, and I'll kind of be your MC for the next 2-ish hours. A little bit about Michigan Sea Grant. We're an organization that is funded through the University of Michigan, Michigan State University, and the National Oceanic and Atmospheric Administration. And we do outreach, research, and education surrounding the Great Lakes and its resources. So that's kind of what's bringing you all here today, I suppose. A couple more introductions. Online, we have one of my colleagues, Caitlin Brolick. She's going to be kind of helping out with everyone that's attending online. And then I'm going to pass it over to my other colleague, Megan Goss.
Hello, everyone. My name is Megan Goss. I serve as a Sea Grant Extension educator in the Saginaw Bay region of Michigan, but very excited to be here today, mostly helping facilitate the virtual connections and looking forward to learning more about the wonderful fishery here in Southeast Michigan.
Awesome. Thank you, Megan. So with that, we are going to get started with our first presentation. So up first, we have Cleo, excuse me.
All right. Well, thanks for coming tonight, everyone. And so to start off, we're going to dive into some regulations and kind of how we go about regulations changes and give you like kind of a little more description of how we handle walleye and yellow perch regulations on Lake Erie. So just to kind of walk you through, talk about the who has the authority to make regulations, and that all starts with the Michigan legislature. So the legislature develops statute that then gives the authority to the DNR, and I'll dive into how that's changed over time to make regulations. The legislature sets up kind of the baseline for what our regulations are, and then we use fisheries orders to then kind of become more restrictive. And in those fisheries orders, we can't go less restrictive than what the legislature has set up, but we can go more. And the legislature also does sets up things like license fees and stuff like that. So that's all done at the statewide level in Lansing. And so then before pre-2014, fisheries orders, again, which is what we use to that's the definitions that kind of what defines the regulations that go into the fishing guide. And before 2014, those decisions for fisheries regulations were all made at the DNR level. So the DNR director was the final decision, final approval before a new regulation went into the fisheries guide. And then in 2014, things changed a little bit. Some of the statute changed, and then the NRC was actually given the exclusive rights to, or exclusive authority to set the regulations for sport fish. And fisheries orders, most of them cover sport fish. That's what a lot of our fisheries orders are consisting of. But we do have some fisheries orders that involve things like minnows and freshwater mussels, things like that aren't sport fish. So those still fall under the DNR's purview for making decisions. But a lot of the stuff that us anglers have look at for regulations, that's all decided on by the NRC. So we now have a better understanding of what our authority levels are. So why do we change regulations? Well, when we think about changing regulations for a fishery, we need to first think about what a fishery is. And a fishery is kind of this three-stool approach of, we have our fish, people, and habitat. And all of these things come in to make that. And so for fish, that's our not just the single fish population, but could be fish community. And our people, those are the people that are engaging with our fisheries, whether that's from a sport fish standpoint, it could be commercial. In the Lake Erie waters in Southeast Michigan, we don't have very many commercial operations, and the only commercial operations we have are going after typically rough fish, and that's down in Lake Erie. But so for people, that comes more into the social realm of what people prefer, what types of fishing they want to see. And in Michigan, we try to do a lot of different, provide a lot of diversity in the ways people can interact with our fisheries. And so that definitely has an impact. And then the third one is habitat. So, the fish have to have somewhere to live, and what that habitat looks like can be very different. So, again, if you think about fish and how we might change regulations around fish, could be based on the population. If the population's going really well and we're getting, have a ton of fish that are available for anglers to go after, we might increase daily possession limit. Or if the population is getting shrunk, or, we don't have quite the return that we would really want, we might have to reduce that population size limit. So these are the kind of the biological reasons for changing a regulation. And then going to the people, again, that's that social piece. So, we have people that might want to have regulations that are more harvest oriented. So they want to kind of maximize the total number of fish that they can harvest while still maintaining that biological piece. So we want to make sure we have sustainable fisheries, and, how many fish can we harvest out of this population? And that might be a very very low, size limit, or a very high number of fish you can harvest, something like that. And that's the biological end. And for the social part of that, that's just for harvest. But there might be people that really want to target that same species, but want trophy fish. And so in that realm, we can still change the regulations that are biologically reasonable, but allow some opportunities where people could go target fish that are, where we have a very more limited bag limit, and people could go there and maybe get to target fish that are able to get a lot older or get to bigger sizes, things like that. So, once we have that biological kind of bookends, the social part and where the people come into play with our angler preferences, that's that social kind of in between piece of, it's not going to harm the individual population or the fish community as a whole, but we have some wiggle room to play in there, and that's where the social realm can kind of come in. And then the third portion with the habitat. So think of, if we have on a river system, if we have a dam, and below the dam, there's one set of regulations, and above the dam is a different set of regulations. What happens when we remove that dam? Now fish can move freely in between. So we might need to go in and change the regulations either below or above to balance that out. Or maybe we change both because of how what that drastic change in the habitat and available habitat then becomes. So lots of different ways and reasons we change the regulations, but I wanted to cover that really quick. And just to kind of walk you through our process of developing proposals for fisheries order changes is, starts out with the idea. And that idea can come from, us from the DNR internally. It can also come from our partners, different ideas. And then that comes, if it's a local, if it's just in Southeast Michigan, that will then go to the local fisheries division for review. So kind of come to my office, and we would gather our givens, figure out how many, what information we have from a biological standpoint, from a social standpoint, what all information we have, compile that into a proposal. And then we take that proposal to our fisheries division basin teams, and our basin teams are made up of, like the Lake Erie basin team would be made up of the Lake Erie Management Unit, as well as our Lake St. Clair Research Station. We have Habitat Management Unit, and we also have our fish production staff, so our hatchery staff representatives on there as well. So kind of bring all of those minds together to kind of think through that proposal, discuss any things that we might need to figure out, and then refine that proposal a little bit more. Once we do that, then we go and try to get even more stakeholder input. Hopefully we've had some before this point. That's kind of the idea at the idea stage and kind of gathering those initial steps. Hopefully we have some of that. And then we try to build on that and get even more. And so some of that stakeholder or angler input can come from just public meetings, coffee and conversations could be used to be a way we would do that as one way. We also have our advisory committees. We have citizen fishery advisory committees. Some folks have participated in that. We have warm water steering committee, a cold water steering committee. Those types of committees are also another way. And we do social surveys. So this is sending out surveys to our license holders. It could be a random draw, could be all of our license holders. And to get feedback, as many respondents as we can to see, what their ideas are based around that proposal of what we're trying to change. And then we take that information, continue to refine that proposal. And from there, it goes to multi-division fisheries regulation review committee, and that's bringing all the different divisions in. So that gives us the opportunity to get our law enforcement folks involved, and for law enforcement division or our Parks and Recs division. So we're looking at this purely from the lens of fisheries. How do we impact? Like, what kind of impacts are we going to have on them, and what thoughts might they be bringing to this? Again, refining that proposal from there. Then it goes to our fisheries chief. And if our fisheries chief signs off on that, it then goes to the NRC for sport fish, again, because the NRC has that final decision point. And if the NRC gives us the stamp of approval, it then works its way into the fishing regulation book. So kind of a long-winded way, hopefully have a little more understanding of what the authority levels are, why we make some of those decisions, and that process that we work through. So lots of checks and balances throughout this whole process as we get things refined and before it ever hits a regulation book for our public to kind of work through. So to go into a regulation that we have for Lake Erie, it's kind of our walleye and yellow perch regulations on Lake Erie are a little unique, more so unique for the walleye. And why might that be? And that's pretty much because Lake Erie isn't, Michigan only has a small sliver of Lake Erie. So, and the Great Lakes as a whole has this oversight commission of the Great Lakes Fish Commission that is in charge of, kind of facilitating the management around the whole Great Lakes. And so they're bringing all these different jurisdictions. When you think of Lake Erie, we have Ontario, New York, Pennsylvania, Ohio, and Michigan. And we all have to kind of come together to figure out how we're going to utilize like the walleye population for Lake Erie, not just in Michigan waters, because walleye don't just stay in Michigan waters. They use pretty much the whole lake. So how are we going to do this? And we have to do this in a collaborative way. And so the Fish Commission's there to kind of oversee that and help facilitate us coming to those decisions. And the way they do that is by developing Lake Committee membership. And that's for Lake Erie, we have the Lake Erie Committee. And again, it takes all those jurisdictions, a representative from each of those jurisdictions sits on the Lake Erie Committee, and they have to come to a consensus decision when they make decisions on things like harvest quotas and stuff like that. So what that looks like from this map's going to show you how that kind of gets set up for yellow perch. And these MU stands, the MU 1, 2, 3, and 4, that's our management units. So for Lake Erie and yellow perch, that we break the lake up into 4 different management units. And the population numbers that we get from the yellow perch and for walleye gets then split into these management units. And for Michigan, we always fall into management unit 1 just because that's where our little sliver is, right over in here. And if you look at management unit 1, you can see we have Ontario, Ohio, and Michigan all in management unit 1 under one, so that grouping, we have to split that amongst the 3 different jurisdictions. And these management units are set up by, the fish stocks, and they're grouped by genetics, geographic distribution, and as well as movement pattern. So again, walleye are going to be a little different than yellow perch. They're not that far off from what you see for management units for walleye. There are some. There's actually a management unit 5 that's over on the east side of the lake as well. But again, for Michigan, we're always in management unit 1. And excuse me, how the data, like how do they come to some consensus with this is a lot of data. So all of these different jurisdictions go out and collect a ton of data. My colleagues from the Lake St. Clair station that you're going to hear from a couple of them later, they spend a lot of time in Michigan waters down on Lake Erie, collecting biological data for yellow perch and walleye and many other species as well. And that's done across all the different jurisdictions. So that's, things like trawling, gill netting, electrofishing, different things like that. And again, done by all these jurisdictions. So it's a lot of fisheries independent data that gets put together. And then we also bring in the fisheries dependent data. So that's the angler harvest, angler catch rates, things like that, as well as the commercial harvest. While we don't have a lot of commercial harvest for any commercial harvest for our sport fishing lake in Lake Erie for Michigan waters, Ontario does, Ohio has some as well. So, those are things that have to get balanced out. And so we bring all of that data together and develop very dense, at least data dense population estimates for these. And so when we get these these population estimates, those harvest quotas then get kind of divvied out through the lake depending on all these different factors. And we get what's called a TAC, so the total allowable catch, same thing as a harvest quota. And so that management unit 1 gets one large TAC. And in that TAC for management unit 1, we then get to split that out amongst the jurisdiction. Michigan has a pretty small piece of that pie, so the amount of TAC that Michigan gets isn't that large. And to make sure that our angler harvest isn't going to like go over that TAC, we then have this kind of setup now. And so instead of having to, because we're collecting data every year and that TAC might change, it does typically change on a yearly basis, not by large percentages, but it very well can. We had to set up a regulation that was going to be able to flex with those changes. And so we developed this regulation that then has a kind of a threshold level. And so if it's over 108,364, if that's what the Michigan TAC is for the year, then we're at 6 walleye per angler. And that's where we've been at for a long time. We've been well over that. Our TAC's been well over that for a number of years, and that is again this year. But if if the walleye population starts to diminish, we want to be able to adjust that, and without shutting the fishery off, just adjust kind of that daily possession limit so that we make sure that we're not going to overharvest the Michigan waters, and we're going to play our role to make sure we have a sustainable fishery out there. So as that population decreases, you can see working down this table, those different bins, and that'll get us down. So if we drop down below 62,000 for the Michigan TAC, we'll be at 1 fish. That's really, really, really low. And I'll show you some more numbers too in a second. But so this is kind of why that regulation kind of has that. We announce it every May, and that will set up the stage for the rest of the fishing season for Lake Erie. So to give you some numbers to look at what 2025 looked like, this is the whole MU1 quota with all 3 jurisdictions in here. And you can see we had almost 2.3 million pounds was the harvest quota or the TAC for management unit 1 in 2025. And Michigan gets about 9% of that based on the amount of water area we have. And so if you look at Michigan, our TAC percentage, we only actually harvested 23% of our TAC for yellow perch in 2025. It's not always the case. We have yellow perch, I actually didn't touch on, which I should have, is set at 50, and that's an exemption from the statewide general possession limit, which is 25. So if you're fishing on Lake St. Clair, you can only keep 25 perch. But if you're fishing on Lake Erie, you can keep up to 50. And even at that higher level of harvest, we still only got to 23%. Part of that's because the fish didn't come in until late. Lots of different reasons for this. But we have had some times where we were very close or even had gone over that percent TAC harvest, but that number is set, and we're pretty confident that most years we're not going to hit over our TAC. And then for walleye, you can see we're still low with 26%. And again, a lot of factors go into that, but our TAC's very high right now. So, we were at 663,000 walleye was the limit was the TAC for Michigan waters. And if you notice that we were at 6 fish, even down all the way into the 108,000. So there's a lot of buffer room there and a lot of room, but if we have really good years, that number of harvested fish can definitely go up. So, and if you look at Lake Ontario, those numbers are really high. They get really close to their harvest because they also have commercial fishing operations that go over there. So they have to balance out commercial fishing and sport fish harvest with those numbers. So to get more information on that, there's a ton of information that our task groups for the Lake Erie Committee put out, especially for yellow perch and walleye. They do an excellent job. There's reports that are available on the website now. If anybody wants to grab this, isn't familiar with the Great Lakes Fishery Commission website, this is the one for the Lake Erie Committee. And with that, I will stop boring you with regulation stuff. Any questions?
So those tax, So the tax are set, and like you said, you pointed out, I mean, right away you see Ontario is right, bumping right up against it. Any penalty for going at 107, or is it just sort of, is there a margin of kind of like assumed error within that?
Yeah, it's a conservative tact so that, you know, we do have some margin of error in that. And again, we've gone over on our yellow perch tack in the past, like similarly, just barely over 100%. And like, I think it was 2017 and fishing was wonderful. Fish came in like August and we were catching, like anglers were catching fish hand over fist. It was an awesome year for perch fishing out there, and we went over. No penalties, like no, but it's, you know, that's always part of the discussion as they come to consensus the next year.
Sure.
Like, how are they going to make sure, like, what, you know, how are they going to try to make sure they're not going to get over that tag?
And I'm assuming you don't know that until the season's over and you
Yeah.
process, so it's sort of like, you're not getting real-time updates that you can tell to shut off the spigot.
And they do a bit with the commercial fishing in Ontario. It's similar to what we do, you know, like commercial fishing in other Great Lakes. They have a good reporting system, so you do get some of that, but there is some lag in that data collection too. So yeah, and that's why we have, you know, these regulations set to try to balance that out.
So within Management Unit 1, can you fish under multiple licenses, thinking of like Michigan, Ohio, Ontario all at once?
It's a great question. And if you're fishing in Michigan waters, you have to have a Michigan license. And so as soon as you start, I'm leaning on my law enforcement folks back there, but as soon as you start fishing in Michigan waters, then you are held to the possession limits for Michigan. So you can't go to Ohio, catch your limit, come back to Michigan and catch your limit. If you would be over your possession limits, once you're fishing in, like once you keep, like say if it's 6 in Ohio, you came back to Michigan, kept a 7th one because you're fishing in Michigan. Now you're over your possession limit and you're fishing in Michigan waters. So no, you can't, pretty much.
All right. Thank you so much.
Thank you.
All righty. Up next, we have Andrew Briggs with DNR. And he will be doing the status of Lake Erie and the Lake St. Clair fishery.
All right. Good afternoon. So my name is Andrew Briggs. I'm a fish biologist with Michigan DNR, the Lake St. Clair Fisheries Research Station. Today I'm going to talk about a lot of our survey work we do on Lake Erie and Lake St. Clair, along with a little bit on some of our individual research projects. All right, so this is kind of the outline I got for the survey or my presentation today. So going to cover a lot of topics on here, so I'm probably going to go a little fast, but start with our Lake Erie surveys, move on to Lake St. Clair, a collaborative survey we do with Ontario and U.S. Fish and Wildlife Service. Talk about our forage assessments on Lake St. Clair, our lake sturgeon assessment, and then give an acoustic telemetry update on what we do with that in one of our acoustic telemetry projects. So starting with Lake Erie. So I'm going to talk about walleye first. So this is targeted walleye harvest out on Lake Erie and Michigan waters. And I'll point out on the upper right here, these are the most recent years. The blue line is the 75th percentile, orange is the 25th. So anything between that's kind of like an average year. So you can see that most recently on the right-hand side, we've had extremely good catch rates of walleye. So the good times are now essentially for walleye in Lake Erie. With yellow perch, this is data from our forage trawl survey we do on Lake Erie and Michigan waters in August. This shows catch of age 2 plus yellow perch. You can see 2025, which is on the lower right-hand side. That's our lowest for the time series. So very low catch of age 2 plus yellow perch, which are essentially the fish that anglers bring home. And that matches very well with our creel data that we get for Michigan waters of Lake Erie. So the blue line represents creel harvest rate of yellow perch. And then the orange line is the trawl data I just showed you guys. And you can see they mirror each other quite well, where 2025, we had our lowest for our trawl survey. And then in 2025, creel was not the lowest ever, but one of the lower harvest rates for yellow perch in Michigan waters of Lake Erie. But possibly a good sign. In our trawl survey this year, we did have very high catch rates of age 0 yellow perch. So hopefully that'll translate to more age 2 plus fish down the road that anglers can bring home. Forage that we caught in the survey, you can see we are getting a decent amount of forage in our survey. So mostly white perch, yellow perch caught in that survey, but we do get some other species as well, such as gizzard shad. Moving on to Lake St. Clair. So this is our collaborative assessment that we do with Ontario and U.S. Fish and Wildlife Service. I'm going to talk mostly about our survey we did in 2025. We have a rotation of gears. I'm going to start with a little bit of background on the survey. So this survey came to fruition in 2021. There was a desire for a coordinated survey to get better data on the fish community in Lake St. Clair all around the entire lake by both us and Ontario Ministry of Natural Resources. And then U.S. Fish and Wildlife Service, they have an early detection and monitoring program for invasive species. So they were interested in getting involved just because the more data we collect is obviously more information for them to see if there's newly introduced invasive species. So these are the surveys we do with that, the gears we use for that survey. We have a nearshore Fike net survey that we've done twice now, 2021 and 2025. GillNet survey that we do every other year, we've done twice. Nearshore electrofishing survey that we've done once, and then we have multi-gear assessments on both the Detroit and St. Clair rivers, where we use trawls, gill nets, and electrofishing in those systems. So I'm going to focus on the Fike net survey, and one thing that was different for this year is, so there's two different Fike net configurations that we've used during the survey. So Ontario, they use nets that have wings on them. So this lower left figure, try to point it out here, there's two wings that come off each side of the net, along with the lead that goes towards shore. Whereas the ones we've used on the American side have traditionally only had the one lead without the wings. So we wanted to see if that was making a difference in catch rate, as in 2021, there are a lot more fish caught on the Ontario side. So we wanted to make sure that wasn't the main contributing factor. And overall, we did catch more fish in the nets with wings, but it wasn't to the level that would explain that large difference in catch between American and Ontario waters. So the 2025 survey, we did 122 total net sets. You can see on the figure on the right-hand side, blue is the Michigan DNR sets. U.S. Fish and Wildlife Service covered the southern half of the Lake St. Clair on the U.S. side, and then Ontario covered their side. So 74 sets in the U.S., 48 in Canada. Took place pretty much all July. Wide range of water temperatures, about 69 to 88 degrees Fahrenheit. Caught 57 species, 57 species and almost 141,000 total fish, over 1,100 fish per net. Most common species were smallmouth bass, gizzard shad, largemouth bass, and bluegill. And with smallmouth bass, largemouth bass, and bluegill, most of those are young of year fish, so fish that were just hatched that year. So going over catch by agency, if you've seen in my presentation on the previous iteration, the 2021 survey, there was a large difference by agency. So I'm going to do that again here. So Michigan DNR, we caught 360 fish per net, representing 40 species. Our most common were largemouth bass, smallmouth bass, bluegill, white sucker, and spot-tail shiner. And the highlighted yellowfish, those are ones that were among the most common in each agency. Fish and Wildlife Service, they caught a few more fish, 427 per net, a few less species at only 30 species, and then similar most common species in smallmouth and largemouth bass, but also gizzard, shad, round goby, and spot fin shiners. And once again, Ontario blew us out of the water. 2,300 fish per net, which is astounding if you have to work up that many fish. 52 species, got your smallmouth and largemouth bass once again, gizzard shad, bluegill, and round goby. So this map here shows the catch rates around the lake. Larger the circle, larger the catch. You can see a lot of large catch rates on the Canadian shoreline there, particularly kind of that southern shoreline and around the Thames River where that comes out. There's a lot more nutrients to come out of there, so that could explain maybe the higher catch rates in that region. American side, we got a lot of smaller circles as we had lower catch. One interesting one was this one in the upper right-hand side. I had to verify with Cleyo that this was correct because they caught a lot of young of year, over 1,000 young of year white sucker in that location. And I believe that was the only spot we caught any white sucker in the entire survey. So that was just kind of an interesting site there. So now comparing 2021 to 2025, and this is corrected for net type. So this is just kind of an apples to apples comparison of the 2 years. So the non-wing nets on the American side and then the wing nets on the Ontario side. So these are our numbers from 2021. 2025, we had a huge increase in catch rate. So 575% more fish caught by Michigan DNR, 238% more by Fish and Wildlife Service, and 377% more on the Ontario side as well. So a lot higher catch this year. Kind of a hypothesis I have is maybe the lower water levels this year maybe made the nets fish more efficiently in some locations, or maybe more fish were willing to be in that near shore waters with the shallower water. Upcoming this year with this survey, we're going to do the GillNet survey again on Lake St. Clair. And we're also working on a report for our first full rotation of the gears. So we used each of the gears in this survey from 2021 to 24. So we're going to kind of summarize everything we caught in Lake St. Clair and the connecting channels as well for that survey. Moving on to our forage assessments in Lake St. Clair. So this is our spring forage trawl survey. We do this usually towards the end of May. Yellow perch is pretty much always the most common species we see in this survey. However, we did have a low catch rate this year. You can see the lower right-hand side, 2025 was one of the lower catches of yellow perch we've had in this survey. And one interesting thing from this year is typically age 1 fish are the most common fish or yellow perch we see in the survey, but this year age 2 and older were the most common for the survey. So that's kind of interesting. That seems like we maybe had a weak year class coming in or something like that. Other common species we caught were emerald shiner, which is the highest we've seen for this survey, the highest catch rate of emerald shiners. Also spot tail shiner, rainbow smelt, and Johnny darters. We also do a fall micro mesh gill net survey. We used to do a fall trawl survey in Lake St. Clair, but there's a lot of vegetation throughout the lake, and that inhibits our ability to trawl. So the micro mesh gill net survey allows us to get better spatial coverage around the lake. And this is a relatively new survey. We've done it for 4 years now. We do 6 gill net sets. You can see the different locations here. We got 2 up in Anchor Bay, 2 kind of around where the Clinton River comes out, and then 2 in the main basin. So 671 total fish caught during that survey, representing 12 species. Yellow perch were the most common. Those are mostly age 0 with some age 1s. Log perch, smallmouth bass, which are mostly young of year, or all young of year most likely. Rock bass and spot tail shiners. And this picture right here is a log perch if you've never encountered a log perch before. Lake sturgeon. So we do surveys for lake sturgeon in both the St. Clair River and Lake St. Clair. This is our spring set line survey we do in the St. Clair River. This year we did 88 set line sets, caught 83 sturgeon, 40 juveniles. So we consider a juvenile under about 40 inches, and then 43 adults. They range the small juveniles, so about 17.5 inches, all the way up to about 71 inches. Wide range of weights, 0.8 to over 100 pounds. We also get a lot of recaptures in our set line survey. About 38.6% of our fish caught this year were recaptures. So fish that we've tagged previously. This shows our catch rates over the time series of our survey. The blue is all fish. Purple is juveniles, and the orange is adults. And you can see our total catch, it does fluctuate quite a bit, but it's relatively stable over the time period. And really the catch rates, they're targeted. The main thing is our mark recapture estimate to get a population estimate, and the population's stable right now, and we have a large stable population of sturgeon. But one interesting thing here is most recently we're seeing an uptick in our juvenile catch. Our juvenile catch has mostly been more juveniles versus adults recently. We did have a few more adults this year, but there's new artificial spawning reefs in the system, so we're hoping that that's a sign that these reefs are working and there's more lake sturgeon recruiting to the population. Our trawl survey, so this is a little bit different. This is in Lake St. Clair, and with this, we catch mostly adult fish. So you can see this year we did 40 trawls, 6 lake sturgeon caught, so we had very low catch rates this year, but all large fish, so all pygosauruses, if you will, in our trawl survey. They range from 58 to about 88 pounds. No recaptures this year. That's another interesting thing, is that we don't get very many recaptures in our trawl survey. Not many at all. So that's one reason this year we started implanting fish with acoustic transmitters, just to get a better idea of what these fish are doing after we tag these fish. And if you look at the graph on the right, one thing that kind of sticks out is the decrease in our catch rates. And then if you look at where the catch rates started to decline, I'll try to point it out here on the screen. Around 2007, 2008, that's where we saw a large increase in water clarity in the lake. And we've seen decreases in growth in some species, but it also seems to be affecting our catch rates of lake sturgeon. So fish are able to better probably see our gear coming and get out of the way of the trawl net. Lake sturgeon harvest. So anglers are required to report their harvest for lake sturgeon in the St. Clair River. For a while there, you can see from about 2012, 2011-ish, harvest was increasing, but it seemed to level off, and now it's dropping back down again. So one thought here is perhaps the popularity of the fishery was increasing. People tried harvesting a lake sturgeon, but now that they've tried it, they're not necessarily interested in doing it once or doing it again. And that's one thing we've seen in our data, is that most people that have harvested a fish, they don't typically pop up again in our registration system as harvesting a second fish. Looking at charter efforts, and charter catch rates. So charter fishermen are required to kind of give us information on their fishing efforts since 2019. So on this figure, the orange is sturgeon caught per trip. And you can see that's been slightly increasing over this time period. Pretty much year over year, it increases a little bit. And then our charter effort has also been mostly increasing year over year. This year it did decline a little bit. Not sure why. Maybe there's a few less people doing charters this year. But overall, it's a pretty popular fishery, and especially considering it's a pretty small area that these anglers target. Generally, they're all fishing in the North Channel of the St. Clair River. Finally, moving on to acoustic telemetry. So we have 4 active studies going on right now. So I mentioned the lake sturgeon at the bottom there. We've did an adult survey or telemetry study in collaboration with USGS back in 2014. We've also tagged some juveniles in recent years, and then we're doing the adults in Lake St. Clair now. We got smallmouth bass, mooneye, and northern pike. And today I'm going to talk about I guess I'll talk about the grid first. So our grid, we maintain our grid on Lake St. Clair primarily with scuba diving. You can see we got a very good coverage on Lake St. Clair with our grid over, at least in the open waters of Lake St. Clair. And we exchange all of our receivers with scuba. But with northern pikes, this study kind of came to fruition with our trap net survey. We had seen there was a little bit of a decline in northern pike, and we wanted to get more information on kind of where these fish are spawning. After that decline, that did kind of rebound in our trap net survey. So pike numbers are doing just fine, but we're still moving forward with our telemetry study. So we tagged 62 northern pike in this study between 2023 and 2024. And most of our fish we tagged a lot of fish, all of our fish in 2023 were in the Anchor Bay area. But in 2024, we tagged fish in several different areas. So around this area here by the Metro Park, Salt River, and then a couple different areas in the Delta here. So I'm going to play this animation. And so from 2023 to 2024, it's going to be all Anchor Bay fish. And then in spring of 2024, you'll see a burst of other fish come into this animation. All right, so there's the fish from Anchor Bay, and you can see they're pretty much staying up north of the lake in Anchor Bay. Very few fish going south. You see a few go down, but most of them are staying up around Anchor Bay. And that's where the burst of other fish came in. And you can see still most of the fish are staying up north, but a few do get down into southern U.S. waters. One interesting thing is we don't see very many fish crossing the navigation channel. So that seems to be perhaps a barrier to these fish. They don't like crossing that channel. That's something we've seen in some other species. Jen's going to talk a little bit about smallmouth bass today. That's one thing we've seen with smallmouth bass. And one other interesting thing we've seen from this study is we're getting kind of different detection rates in successive years in this acoustic telemetry study from different areas where fish were tagged. So in the upper right is a table showing the different areas that we've tagged fish, and the map shows those areas. So for example, Anchor Bay, we tagged a lot of fish there in trap nets, and then again in 2024 in some nearshore areas. 86% of those fish were detected the second year they were at large of that study. But then you can see there are several areas up there, Black Creek Marsh, Mud Lake, which is here in the Delta area, and Muscatine Bay, very low detection rates there. So that led to some other questions. So is this due to receiver coverage in the lake? A lot of our nearshore areas perhaps don't get as good a coverage where northern pike are likely hanging out. So that's one question we have is maybe our receiver coverage isn't great for northern pike. But also, is there higher mortality in some areas? Are there areas maybe anglers are targeting pike more than other areas of the lake, and perhaps there's just higher mortality in some areas of the lake than other areas? So to get at these questions, we did increase our spatial coverage of our receiver array. You can see the left is the previous array, the right is the current array. You can see in kind of this shoreline area here of Anchor Bay up here, we have a lot of receivers up here for the spawning period. There's different areas where fish can get into some canals and areas that access wetland habitats. We wanted to cover that. We got some extra receivers in the channels of the lower St. Clair River to try to get pike that are exiting perhaps those bays of the Delta. So hopefully this year we'll get increased detection rates of some of those fish, or we'll confirm that maybe there's higher mortality in some areas. And also to get at the mortality question, we're putting some external tags in northern pike that we're catching this year. So we've been out the last few weeks tagging northern pike with these external tags. So anglers are going to be able to report these to us, and hopefully we'll get an idea if people are catching a higher percentage of these fish in certain areas of the lake and harvesting more of these fish in certain areas of the lake. So if any of you guys fishing in Lake St. Clair and either target northern pike or come across northern pike, be sure to look for these tags, and you can report them at our website here, michigan.gov/tagged fish. But with that, I'll be happy to take any questions.
Yeah, so stepping back to the pike nets earlier in the presentation, you sort of mentioned how there was a lot of variability in catch rates among all of the nets that were placed throughout. And you touched on like the Thames River and stuff. So is there any way to sort of look into what other variables are correlating with those catch rates, like river mouths or nearby nursery habitat or other things like that?
Yeah, so that's one that we haven't looked at all that we do collect vegetation information at each site, depth at each site, turbidity at each site. So that's one thing we do plan to look at. We have seen that one variable that kind of stuck out the first year was on the Ontario side, they have a lot better nearshore habitat. So on the American side, it's about 90% hardened shoreline where we set our nets. Whereas on the Ontario side, it's about 52%. So they have a lot more wetland habitat, which is obviously better habitat for fish and especially nursery habitat. So that's probably a key factor, but that's one thing we want to look into further.
Yeah, thank you.
This is a question from online. After netting the species, where do they end up?
For which survey, I guess?
I think this was when you're talking about the pike nets.
So after we work up the fish, yep,
Mhm.
every fish gets released during the pike net survey. So they're all back in the water. Yep.
And then there's one more question. Catching fish is fun. Thanks for the limits, guidelines, and how they are reached. At the end of the day, are the fish safe to eat?
So there are eat safe fish guidelines. So there's, I guess I'm not an expert on that, but there are for most fish, I don't think there's any do not fish eat advisories on Lake St. Clair currently, but are there some do not eat? Okay. Muskie. Okay. So muskies are do not eat, but for most species, you're able to eat at least a certain portion of fish per month.
Okay, thank you. And we did share the Eat Safe Fish guidelines
Yes.
in the
Yeah.
chat.
Yeah.
Have any studies been pursued about catch and release fishing and mortality as far as the sturgeon and other fish? I mean, it was a little different than perch fishing where people, certain size, they keep them,
Yep.
But-
So for lake sturgeon, we have looked into it, and it seems like there is not much catch and release mortality for sturgeon. I'm sure there is some, but the work that we've done has shown that it's not at a level that's making a population level impact. So it seems to be low enough that's not having an impact on the population.
Any
Dan's
thoughts
going to talk more about smallmouth bass too. That's another species we've looked
any
at.
thoughts on why the perch come down besides possible over harvest?
Perch in Lake St. Clair.
Yeah.
So one thing is we've seen a decline in growth of yellow perch in Lake St. Clair. So perhaps there's not as many getting to the larger sizes that you've looked at. So our overall, like we did have fewer perch caught in our trawl survey in the spring this year, but overall it's been pretty steady. So it seems like it's more of a growth issue that's going on.
It's a what?
A growth issue. So fewer fish making it to larger sizes.
Oh, yeah, but you guys kind of measure them on a state average to a water body and growth rate per water body. Over
Correct.
an average, right?
Yes, and right now the yellow perch have been declining in Lake St. Clair. What we've seen is there's a large kind of ecosystem level change in Lake St. Clair and Lake Huron. There's fewer nutrients available and fewer prey in the lower food web available to young yellow
Plankton kind
perch.
of thing.
Yep, exactly.
Okay. Thank you.
Any ideas how big of an impact the cormorant has on the perch?
So not really on Lake St. Clair. I mean, I think there's some areas of the Great Lakes where people have done studies on their impacts, but on Lake St. Clair, not a lot of information on how much impact they have in our system.
Hi, you mentioned you do all of your pike nets near shore. Is there any reason why you wouldn't do them offshore or kind of in the middle of the lake?
Yep. So the pike nets, I go back there, they work more effectively in the nearshore water. So technically you want the net to be just peeking out of the top of the water. So that because there's a lead that goes to the net and you don't want fish to be able to swim over top of the lead. And also you want it sticking out of the water in case you get turtles, something like that, where they can come up and breathe. So that's the main reason we don't set them in deep water, just because they're more effective in the nearshore zone of the lake. with our GillNet survey, that's kind of the survey we use for offshore water. So each of our surveys kind of use to target different portions of the fish community and different habitats of the lake.
Do you have anything to note regarding muskies and their population in Lake St. Clair?
So muskies in Lake St. Clair. So Jan's been doing some survival, I think. I don't know, Jan, is there anything?
Sure. Thanks, Andrew. Yeah, we have been pursuing a acoustic telemetry study for a number of years on muskies in Lake St. Clair, and using the data that we get from that to calculate fishery metrics like their survival rates, which is something that's actually like pretty challenging to achieve for fish like muskies that you can't really hold on to very well. So muskies on Lake St. Clair have a pretty low mortality rate overall, but we have seen reports mostly from our charter anglers that the catch rates have been declining. So there's sort of a mystery and something that we're working on trying to figure out right now.
Thank you. And there's one more question online. Are there artificial reefs beyond those for sturgeon?
So the artificial reefs, I mentioned but they're for multiple species as well. So any species of fish that would spawn on rock reefs are able to use these reefs in the system. So species like lake whitefish could use these reefs. Walleye eggs have been caught on the reefs, and eggs of several other species as well.
Great, thank you.
All righty. Thank you so much, Andrew. Next, we have Jan-Michael Hessenauer with the DNR.
All right, thank you. Good evening, everyone. So my name is Jan-Michael Hessenauer. I'm one of the research biologists at the Lake St. Clair office with Andrew, and excited to talk to you guys tonight about the impact of year-round catch and release on smallmouth bass. We had a timely question over here earlier, so I hopefully can provide a little bit more clarity on that topic. This is something that I've been working on over my career with the DNR and in graduate school as well. So it's something that I've worked on quite a bit that I'm excited to be able to share with you today. Perfect. Okay, so as many of you I'm sure know, Lake St. Clair is a special place, both as a place to go fishing, and it's very ecologically interesting as well. So has absolutely world-class fisheries for smallmouth bass, muskies, gets a unique opportunity to catch lake sturgeon, like Andrew mentioned, and then really respectable fisheries for walleye and yellow perch as well. Ecologically, it's an interesting location because it's the border between the upper Great Lakes and the lower Great Lakes. So you have a mix of warm water fisheries that you would expect with the lower Great Lakes, like Lake Erie that Cleyo was talking about. And then some of the cold and cool water fisheries also come down from Lake Huron, which make it just a really interesting place to go fishing. When you cast a line in Lake St. Clair, you really never do know what you could potentially catch, which makes it an exciting place to work. So smallmouth bass, of course, on Lake St. Clair are one of the fish species that it's best known for. It's consistently rated as a top 10 lake by Bassmaster magazine. And our office has been interested in smallmouth bass for a very long time. We've surveyed it intermittently from 1972 to present. So we have a really long time series of data to look at. And that's come in really handy because Lake St. Clair has also been the site of really profound ecological change. So, in the middle of the last century, it was pretty profoundly impacted by the industrial legacy of this area. It started to improve dramatically thanks to the clean water legislation in the United States and Canada. And so that has resulted in really dramatic improvements in water quality. But on the other hand, it's been the site of two of the most nefarious invasive species in introductions that have impacted the Great Lakes, being zebra mussels and then later quagga mussels and round goby as well. And those two introductions had really profound impacts on the flow of energy through the system. So before their invasion, there was a lot of fish out in the open water, and that tended to be the path that energy moved through the system. And after they were invaded, all of that energy got sucked down to the bottom of the lake and was most available to fish that were able to eat things off the bottom. So that's resulted in some species that have been perceived to be winners of this invasion, and some species that have been perceived to be the losers of this invasion. And across all of this, we've had natural fluctuations. So one that comes to mind that really impacts Lake St. Clair and the Great Lakes in general is just the annual or the cyclical change in water levels. So we've been through some really high water level periods, and now we're coming down to perhaps some lower water level periods, and that can impact fishing success and the recruitment or spawning success of other fish species as well, as Andrew mentioned. Another thing that's changed a lot has been how anglers behave, and their motivations for fishing have changed quite a bit in recent years. So this graph shows the harvest of smallmouth bass from the American waters of Lake St. Clair over 3 kind of distinct time periods. So creel surveys, which is one way that we can measure how many fish are being caught and harvested by anglers. Have occurred sporadically, but you can kind of see in this earlier time period here in the mid 80s, we were having over 20,000 smallmouth bass harvested from Lake St. Clair each year. Another set of surveys happened in the early 2000s, and that number had dropped to, in the 10, 12, 15,000 fish per year range. And then our most recent cluster of data points show that fewer than 5,000 bass were being harvested, or around 5,000 bass were being harvested. So that's a pretty substantial drop off over that time period. And I believe that the primary reason that this is occurring is because most anglers fishing for smallmouth bass have switched to a catch and release based practice. So it's no longer for those anglers about bringing fish home to eat. It's about the experience of catching them and then releasing them further. And catch and release has a couple ways that it can still impact populations and can be controversial depending on different people's point of view. But one way that I think a lot of controversy arises is looking at the impact of catch and release on individual fish, and then contrasting that with the potential impact for catch and release on the entire fish population. So we're going to kind of walk through these two different aspects and talk about it. And I'm going to share with you where some of the research is, including some of the work that I've done both here at the DNR and previously as well. So at the individual level, most people are typically worried about catch and release during the spawning season. So for those of you that don't know, one of the things that makes smallmouth bass really cool is that the male bass will excavate a nest in the ground or the sediment of the lake. Female bass will come and deposit eggs in that nest, and then the male bass will guard that nest for up to a couple of weeks. And during that time, the male bass is very visible, very easy to see, and pretty vulnerable to being caught. So if you throw a lure into a bass's nest, that bass is going to pick that lure up and try to move it out of the way, and that's a really opportune time to hook that fish and catch it. And I think the research in general is pretty clear that catching a male bass off his nest is not good for that male bass. There's been a couple of different studies here that show a couple of different experiments that they did. So they had control fish that they did nothing on. They had angled fish that they caught off the nest, and then they did some simulated predation. So when the male bass was off the nest, the researchers removed some of the eggs from the nest. And then they also caught the nest or caught the fish and did that simulated predation. And what you see is when you remove eggs from the nest, the male is more likely to abandon the nest. So it's actually fascinating, but the male bass is able to look at his nest and see how many eggs are there and decide whether it's worthwhile to stay and guard that nest. And fishing is removing that bass can promote predation of the eggs and reduce the chance that he'll stay and guard the nest. And if the male leaves, then the nest will fail. This is another similar experiment, I think conducted in Lake Erie, and just shows similar impacts. So removing a male bass from the nest increases the chance that that nest will fail, which people have argued will lead down the line to population level effects. But that has largely not borne out in the literature. So it makes sense that at some level, logically, you have to have bass nests to have recruitment and adult fish to catch later. But the relationship between the number of nests that are required to have an adult population is not known. And that comes down to what we call compensation. So there's really high compensation in bass. And I think of this as like if you're having a party and you put out a bowl of chips, right? It doesn't matter how many people are at your party. At the end of the party, there's going to be one burnt, like gross chip left in that bowl that no one wanted to eat, right? But the difference is the amount of chips eaten by each person. So when you have a lot of nests that are successful, you have a very high density of fish that are left. That means there's less food or fewer chips available to those fish. They don't get as big. Being big going into the first winter is the main predictor of survival. And so if there are many bass in the fall, they're not as big. That means more of them die in the winter. And in the spring, you end up with about the same number you would have if you had fewer fish. So if you remove some nests due to angling or just natural failure, there are fewer fish. They have more food available to them. They're larger going into the winter, and they have better survival. So this is a study that was done in New York, I think, and they found in this particular case that they actually had more fish after they instituted a catch and release season than they did prior. And I don't think they were arguing that catch and release increased the population, but it certainly didn't harm it at the population level. So the impact of catch and release on bass kind of depends on which level you're looking at it. There are, though, some additional considerations that I wanted to talk about. And then what I'm going to do is kind of walk through some metrics on Lake St. Clair, and we're going to look for some of the effects that we might expect based on catch and release. But some additional considerations before we move on to that are that one of the other things that's really fascinating about bass is that some fish are genetically more predisposed to being vulnerable to angling. So some fish are easier to catch because of their genetics. Because it's genetics based, they can pass those traits on to their offspring. And those traits tend to be correlated with other features that are of interest, especially to anglers, like aggressiveness or parental care, and even some physiology features. So this figure shows some work that I did when I was a graduate student at the University of Connecticut. And in Connecticut, they get a lot of drinking water from drinking water reservoirs, and they protect their drinking water by excluding people from those reservoirs. So there's these big lakes that have bass populations where no one is allowed to fish or has ever been allowed to fish. And what we found was that bass in those lakes had higher metabolic rates than bass that came from publicly available lakes. So what that means is that those fish require more calories to just carry out their daily lives. And those calorie requirements may be what make them more vulnerable to angling. So if you have a higher metabolic rate, you need more food. Angling is typically trying to trick a fish into eating something, right? And so those fish might be more easy to catch than fish that are from the exploited lake. So what this shows is sort of a trend, possibly driven by angling, towards a lower metabolic rate in bass. Another thing that we found, and this is some simulated data, is that even very, very low rates of catch and release mortality can impact the size structure of the population in a way that's sort of similar to harvest if there's enough fishing pressure. So in some of these lakes that I was looking at in Connecticut, there was so much fishing pressure that the number of catch events in the lake exceeded the population size. So basically every fish was being caught more than once in a given year, which is just, so probably not what's happening in Lake St. Clair, but could be happening in a smaller inland lake. And as you ratcheted up the catch and release mortality, what you saw was a decline in these bigger fish that anglers are potentially the most interested in. So as catch and release mortality approaches 5%, you're seeing a big drop off of these larger fish in the red boxes there. And even, a catch and release mortality rate of only about 2% was having, I think, about a 25% reduction in some of these larger size fish that anglers might be most interested in. So that's sort of an extreme example. That's probably not happening in Lake St. Clair, but it is still a consideration of the potential for catch and release mortality to impact populations on the whole. So now moving on to Lake St. Clair in specific. This is sort of a recent Lake St. Clair regulation history. I thought 1976 was far enough back in time that it wasn't necessary to go any further back than that. But in specific, we're going to be looking at these two recent changes. In 2006, spring catch and release fishing was permitted, so that was allowing people to fish while the bass are on their beds. And then in 2016, we added year-round catch and immediate release season as well. So we're going to be looking at these 4 metrics for Lake St. Clair: biomass, size structure, mortality rate, and recruitment. So now I'm going to show you a series of graphs. Each one will have these 2 regulation changes kind of denoted with a vertical line, and we'll just kind of talk through the axes together and look at the data. So this first graph shows on the y-axis, this is the number of kilograms of smallmouth bass per 24-hour lift. So basically just trying to standardize for our trap net survey the weight of bass that were caught in a given year. Here's our 2 regulation changes, and you can see that basically there's a steady flat line across time. So there's been, from this figure, we haven't seen any impact on the amount or the weight, total weight of smallmouth bass present in the lake across those 2 changes. This figure is a figure that shows the size structure of Lake St. Clair. So proportional size distribution is a metric that we use to look at the number of adult fish that are at or above a given threshold. So for example, this figure shows the number of fish at or larger than 14 inches in our trap net surveys, at or over 17 inches, and at or over 20 inches. And you can see that across the time series, those metrics have been rising. One thing that was, so we didn't get to do a survey in 2020 for obvious reasons, but we did notice a pretty steady, sharp drop, which has then rebounded in recent times. So one thing that was in the news quite a bit was that there was a big bump in outdoor activities like fishing as a response to the COVID pandemic. So I'm wondering if that may have driven that change, but we've seen the population recover to basically pre-COVID levels in terms of size structure. So overall, size structure has been increasing and improving, which this is what we like to see. This means there's a lot of large fish out there available for people to catch. This figure shows the annual mortality rate. So this is basically can be thought of as the proportion of fish that aren't expected to survive from one year to the next. So an annual mortality rate of 30% would mean that if you started with 100 fish, by year 2, you would be down to 70 fish. Just to put it into simple terms. So again, here's our 2 regulation changes, and you can see that there's been a slow but somewhat steady decline in mortality rate across the time series. This is our estimate, and then the gray bars up below and above that line are the confidence in that estimate. So generally speaking, there's been a slight decline in mortality rate across the time series. And then the final metric that I wanted to show you was a measure of recruitment. This is from our fall trawl surveys. This survey is discontinued, so that's why the bar ends here at 2023. So I've got the number of smallmouth bass young of year per acre on this axis, and then this line shows the size of those fish. So here you can kind of see that like chip bowl phenomenon that I was talking about with years with really high recruitment tend to have smaller sizes and vice versa. So across the time series, recruitment varies, but has generally been flat. The highest recruitment period occurred after the catch and release season was implemented in the spring. And then there were a number of years below. This is the time series average in both periods. So to kind of summarize, across those metrics, since 2006, biomass has been stable. The size structure of the population is improving. Mortality rate is stable to improving, and then recruitment is stable as well. So we really haven't seen much of an impact of catch and release, if at all, on the metrics that we track for smallmouth bass in Lake St. Clair. If you're interested in this, we've published a recent paper that talk a lot about these metrics and go further back in time as well, starting to the beginning of our station's history in the early 70s that show some of those those trends across a wider range of time. And then I did want to just really quickly talk to you about how we're monitoring the population now and into the future. So we've been doing a lot of work with acoustic tagging, as Andrew mentioned. That's a technique that allows us to track the fish in much finer detail than we're able to through external tags. So the fish are surgically implanted with a tag. That tag emits a pinging sound that can be detected at listening stations throughout the lake. So Andrew showed you that image of the grid. That allows us to detect these fish and track their movements across time. It is really big data. So we've had like over, we're approaching 1 million detections of these fish. So 1 million individual data points of where we knew where one of these fish were. We've had a lot of these fish caught by anglers, which provides a really unique opportunity to look at survival in a catch and release sense after they've been released, because we're tracking them through the environment after they've been reported captured. Like Andrew showed, smallmouth bass show really tight spatial aggregations. So the fish in red were tagged in Anchor Bay, the fish in blue were tagged along the mile roads, and those two groups seem to stay kind of separated from one another and also don't cross into Canada like Andrew showed for the pike, which is just really really neat. In a couple of the recent years, we've tagged fish in Canada as well, so it'll be interesting to confirm that the reverse is also true, that the Canadian fish aren't crossing into American waters. We're getting really interesting and unique data from this. So this is a figure showing the home range size of an individual smallmouth bass. So this can give us a sense of the quality of habitat, how much space an individual fish needs to carry out its life. And then bringing it back to angling, looking at things like these are those home range sizes. This is for fish that were and were not caught by anglers. So interestingly, fish that were not caught by anglers tend to have larger home ranges and move more than fish that were caught by anglers. So just a really interesting way to tie it back to their basic physiology. So maybe fish that are more vulnerable to angling just stay in specific areas and don't spend as much time roaming around the lake as fish that are not caught by anglers. So really interesting trends there, but I've talked to you guys a bunch. We'd be glad to take any questions. If you come up with anything later, please feel free to call me or send me an email address. And if you catch one of our tagged fish, whether it's a pike or a sturgeon or one of my bass, please report it to us, because that data is super, super valuable to us. And you can go to michigan.gov/taggedfish, and there's a pretty easy form to fill out. And you'll get a letter from Andrew or I that tells you what we know about that fish. So it's a nice way to learn about what the fish that you caught has been up to. So with that, I'd be glad to take any questions, and thanks a lot for your time.
What sorts of helpful information do you get resulting from the big fishing tournaments on Lake St. Clair, if any?
Yeah, that's a great question. So we have been to a couple of the recent Bassmaster tournaments on Lake St. Clair, and we've tagged some fish at those events. So that was a really great way to both get our message out to their audience, and an opportunity to have a bunch of fish aggregated together to tag. So we tagged fish at the Bassmaster tournament in 2022 or 3 maybe. It all runs together after a while, but we also, last year, they had a big event. One of the Bassmaster tournaments was there. So I went there for one night, and a couple of other colleagues went for another night to look for our tagged fish. So it was just a great way to see a bunch of fish that were caught from all over the lake and bring them to one spot and look for our tags. So that's been a really good collaboration.
So you showed a pretty cool graph of the drop in smallmouth bass catch and keep, 25,000 down to 5,000. Do you have a sense that I'm assuming that's not something specific to Lake St. Clair. Is that something that's probably echoed broadly in the fishing world, I would say, especially in the bass angling world?
Yeah, I think so. I think that's been a general trend. I mean, there's certainly regional variations in that, but here in like in Michigan and also in the Northeast, that was a very common overall trend.
Awesome. Thank you so much. All righty. Up next, we have Kevin Goodwin and Josh Tellier with EGLE. Also, I know on the agenda, it said that Scott Dirks was next, but he's unable to make it, which is why we're just moving on to the next speaker.
All right, good evening, everyone. My name is Josh Tellier. I'm an aquatic biologist with the Michigan Department of Environment, Great Lakes, and Energy. And Kevin, my colleague Kevin and I were asked to provide a little update on the muck situation in Lake St. Clair. So switching gears a little bit from the fisheries focused world and talking more broadly about some of the strategies that we've been working on to manage the muck issue in Lake St. Clair. If you've done any amount of fishing or recreating in L'Anse Creuse Bay, or working off the DNR boat launch here in Mount Clemens, you're probably familiar with the muck. But the question that a lot of people have is, what is this muck? The scientific name is Microcera woolii. Formerly, it was called Lingbia woolii. So if you're looking at some of the older literature on this muck issue, you might see that Lingbia reference. It's just a change in nomenclature. It's now called Microcera woolii. And functionally, it's a cyanobacteria, which is a blue-green algae. You might be familiar with those blue-green algae in the Lake Erie context, where they form a lot of those in the water column algae blooms. Microcera woolii is actually a benthic algae. And so in this species, you have individual algal cells that are stacked together into filaments that form a protective sheath. And then those filaments grow on mats on the lake bed. Here is a picture of Microcera woolii under a microscope. And so what you can see here is that going across the screen is one of those filaments, and the individual cells are stacked almost like CDs or discs along that filament. And then zooming out a little bit from that microscope view, if you look in the upper right portion of this figure, that's just a little bit zoomed out, and you start to see those individual filaments and clusters of the algae, the muck. And then at a macro scale, this is what you see on a net or otherwise, where those filaments, those fibers kind of cluster up into these pellets due to wave action. And like I mentioned, it has a benthic growth habit. So when it's actually alive and growing, it's on the lake bed here. So here's a picture from underwater where you're looking down at the lake bed, and all of that sort of dark surface that you see is the algae growing. And it's kind of hard to tell with the glare on that right side, but there is a large bed of the Microcera growing there as well. So when we start to see these shoreline accumulations, particularly in L'Anse Creuse Bay, a lot of that is driven by the wave action and the currents of the lake. So here's a couple individual pictures kind of stacked up against a seawall there. You see when it starts to accumulate in that corner. And then later on, as it continues to accumulate, you eventually start to get other plants and things growing on this mass because it's become so stabilized in that situation. So that arrow is kind of pointing to greenery that's growing on top of this stuff. And in that there as well, you can see dead fish and other debris. So it's understandable why this is kind of a nuisance issue for a lot of people that live along the shoreline there. Here's a couple of pictures that I took at that DNR boat launch in Mount Clemens. If you're not familiar with it, they recently, last year, a year before, 2 years ago, moved the boat launch location because the old boat launch was being so inundated with this material. And so what you see here is some Microcera accumulations just along the shoreline. And to kind of point that out a little further, if you look at these two lines, the dashed line there is sort of a more recent accumulation where this stuff is piling up. And even that solid line is just older Microcera that's piled up, and other things are now starting to grow on that. And even on the newer material, you're seeing geese and things walking along there. So this stuff can become pretty stabilized along the shoreline and really pack in. Where is it found? This has kind of been our focus area for a lot of these studies, is we've primarily seen these accumulations occur, like I mentioned, in that L'Anse Creuse Bay area, and particularly south of the Clinton River Spillway. However, it's not unique to this area in North America. So you see a lot of these red dots here on the map. These are all confirmed locations where Microceria woolii has been found in North America, both in the US and Canada. So there's some older records of it from the Northeast. They've had a ton of nuisance issues with it down in the Southeast and Alabama and Mississippi and Florida. And there's even some records of it up into Canada. So it's widespread. However, the issues that we're seeing on Lake St. Clair are unique in the sense of the massive accumulations and piles that we see along the shoreline there. Another question that a lot of people ask in the context of this Microceria, because it has started to develop more of a nuisance condition in the past couple of decades, is whether or not it is an invasive species. That's a common question that we get. And the answer is that's kind of unclear. There are some literature sources that define it as an invasive species. However, we do have confirmed preserved specimens back from the late 1800s of this species in North America. So if it is indeed invasive, it's been here for a very long time, over 120 years. And here's a little bit of a timeline of events, major happenings to do with Microceria woolii on Lake St. Clair. So prior to all of this, a study in 1984 of the algal community of Lake St. Clair noted that less than 20% of that algal assemblage was comprised of cyanobacteria. So what that means is in 1984, less than 20% of the algae that was seen in the lake was anything related to this species. A little bit later in the late 1980s is when we start to see those dry-cinded mussels come in, right? So the zebra and quagga mussels that often work to sort of clear up the lake and increase water clarity. And then by 1994, there were a lot of anecdotal reports of floating and submerged mats of algae observed during different studies. So that's where we started to notice more Microceria woolii. By the late 2000s, the growth of this species was recognized as an issue, as a nuisance for some nearshore communities. And then in 2015, we started to receive a large uptick in the number of reports of this nuisance accumulation in coves, embayments, and along seawalls on Lake St. Clair. So all of that culminated in 2022. Macomb County reached out to the U.S. Army Corps of Engineers and several other partners, including EGLE and universities in the area, to initiate a study to try and better understand this species, what it's doing, why it's here, and to identify management actions. So in the past couple of years, 2023 and 24, that's led to some intensive field and laboratory efforts that we'll be talking a little bit more about going forward. So like I mentioned, this is kind of the culmination here is this Army Corps Macomb County study, partnership amongst several agencies, really with the goal of developing a management plan. What can we do about this muck issue? How can we manage that for the future? And that resulted in 2 years of fieldwork and laboratory analysis, partnership with Army Corps scientists. So in 2023, we held that initial meeting where everyone came together and then sort of formulated a plan of what we're going to do. That also involved some collection of the Microceria biomass from Lake St. Clair for lab work. And we also started an in-depth literature review to learn more about this species. 2024 was a lot more of an intensive fieldwork and laboratory year. There was biomass sampling, environmental DNA sampling. The Army Corps had this really sweet, awesome underwater drone that was like an automated drone that flies around underwater and takes pictures of the lake bed. And then there are also some aerial and satellite imagery surveys to kind of track the movement of these accumulations along the shoreline, how quickly they're piling up and whatnot there. With the end goal of this adaptive management plan, how can we manage this to best preserve the lake resources? And some of the major findings of those 2 years of study. So it was found that the Microceria woolii remains viable in shoreline accumulations for some time before drying out. So that first year, they collected the material from both within the lake on those lake bed clusters, as well as in places where people had piled them up on the shoreline in attempts to remove them from the lake. And they found that when they brought those back to the laboratory, they were able to foster growth in both the lake species and also the specimens that were on the lake shore but had not yet dried out. They were effectively able to resuscitate them before they fully died off. And it was also identified for the toxin production potential in this Microceria woolii. So there were detected the genetic markers for toxin production, which we wanted to look more into. And it was also found that this species is adaptable to many conditions. It can fix its own nutrients like nitrogen, and it tolerates lower light conditions than many other aquatic plants in Lake St. Clair. And then in 2024, we learned even more about it. So we kind of started to scope out the spatial distribution of where this was found within the lake. So like I had mentioned, that cool underwater drone, they did several flights of that drone throughout the lake, and the mats were detected over 1.5 miles offshore. And that was as far as the drone went. So there's a potential that those mats are even further offshore than that. But essentially, the upshot there is that it covers a large spatial extent in that L'Anse Creuse Bay area. And growths were found to be most prevalent at depths of less than or equal to 12 feet. But for Lake St. Clair, that's a good portion of the lake, right? It was also found that those shoreline accumulations were more likely to be driven by transport than local growth. So they did bagged studies where they essentially sectioned off a portion of that Microceria woolii near the shoreline to track its growth over the growing season. And they found that it was essentially equal growth and decay. So the fact that there was material accumulating over the summer meant that that material was coming in from elsewhere, likely offshore deposits of that benthic growth. And then waves, currents, and whatnot were driving it into those nearshore areas where it was kind of getting caught up in the coves, along jetties and whatnot, basically where there are structures that it can get caught into. And then we also identified the importance of considering wet versus dry weight for future management actions. You know, like most algae, this is a high portion of this organism is water, right? So if you're trying to remove it, it's best to let it dry out first so that that water weight can really cut down and you're not having to deal with as much mass. And I'm going to turn it over to Kevin to then talk about, here's what we have learned. Well, what's next for the management of the species?
Thank you. Yeah, so I'm Kevin Goodwin. I'm a coworker of Josh's with EGLE. I'm another product biologist. So I'm stepping into the what next. Again, as Josh mentioned, this Army Corps Macomb study really was focused at coming up with an adaptive management process. So kind of a sort of like try it, learn what you learn, and try something new if it didn't work kind of approach. A big component of that is as some funding that came through this year's state budget, specifically in kind of a line item that was co-sponsored by Representative St. Germain and Senator Hertel, to actually funnel $800,000 in the state budget to Macomb County to continue kind of taking the study that the Army Corps did and sort of putting some of that into implementation and seeing what we can learn in these next stages. So that $800,000 is a one-time fund that we're going to spend over 3 years to support kind of managing, trying to mitigate some of this and trying to learn from that to see if we can broadly kind of scale up what we learn from that process and trying to figure out what can be effective and what can be either get short-term or long-term assistance in managing Microceria. So it's really taking the study work that Macomb and Army Corps did and kind of taking it into more of an implementation phase. So that state funding this year brings, again, this money is going to Macomb County, whose Public Works is the lead in this process, but they formed a technical team. I sit on that from an EGLE perspective, but we also have Army Corps folks on that who were involved in that original study to bring their expertise in with it as well. At this point, we're identifying shoreline locations. Again, as Josh noted, we're generally talking about L'Anse Creuse, kind of Macomb County shoreline. Looking at locations all along that have this kind of historic buildup and trying to identify certain ones that are better suited to try to do some removal and see if we can learn from those areas and sort of extrapolate that to other places along the shoreline. So we are literally kind of at this moment getting close to putting forth a request for proposal. We'll be identifying spots along the shoreline, specific locations that we want to target as removal areas, looking to kind of dredging contractors, those in the area who are actually do this sort of work to see what sort of tools they can bring to address these like very near shore. You know, this is a little different than dredging out a canal or dredging offshore because what we're talking about is this shoreline buildup. So whether somebody's used to dredging from shore and digging stuff out from there or from lakeside digging up, we're in that zone of like zero depth to 3, 4, 5 feet. So it's going to be potentially a fairly difficult technology to do that and not also then disturb, lake bottom and all the other things. So we're really trying to look to our dredging folks to see what sort of things they can bring to the table from techniques and technologies to sort of mitigate this work, take this stuff out. The plan is to monitor both before at these places, before the dredging happens and afterwards, so we understand how much we've removed. There's also an indication we want to know not just how much stuff we removed, how much biomass, but also how much kind of nutrient mass that relates to, because the other part of this is that there's a nutrient component to all of this that also is relevant to downstream issues, right? So like every bit of kind of plant material and stuff we get out from here isn't going to deteriorate and then move down to Lake Erie and kind of feed blooms down there. And so there is a interest in trying to learn what sort of nutrient removal we're going to get from some of this. The important part then is going to be how long it takes to come back. Because places where we've seen this removed in the past by homeowners who've gotten together and gotten a permit to do this and spent a lot of money, and sometimes within a month it's back. And so obviously that's not only not ideal, but it's frustrating and it's kind of not a great way to spend your hard-earned money. So that's where we're trying to learn, pick sites that we can extrapolate what we've learned from those places to other ones similar to it up and down the shoreline, because it's a big issue. So really the primary focus of this $800,000 this year will be going to removal, kind of studying the befores and afters of that, how long that removal is successful, and then when the stuff comes back, if it comes back, trying to learn from why it does, where it has, and what we can do then in the future to mitigate that. There's been discussion, as Josh pointed out in that one picture, this is an aerial of Metro Park and kind of the wetland to the west of it. All that dark lining that you're seeing there is sort of mycoceria growing or staging up to be washed in. So stands to reason if you just dig it out along the shoreline without addressing some of these other bigger issues that should be coming back pretty quick. So that's what we want to learn from some of this work and then talk about what approaches are even viable to address that offshore if that's something that needs to be addressed. Because once you start moving away from the shoreline and going offshore, logistically it becomes almost nightmarish as I think about it from a regulatory standpoint. And also, as we talk about the value of the lake bottom and all the other things happening out there and the potential to like kind of mess with everything else we've been talking about here, right? The ecosystem dynamics will be a massive thing to consider if this doesn't work on the near shore. So, but we keep saying you can't tell it's not going to work until you try it and see if it works or not and learn from that and kind of move forward. So I appreciate that, again, the legislators have gotten some money to try to implement some of this work, to at least test some theories and start to see what may or may not work. So that's where we are with the state funding. We've got a couple other things that are going on outside of that. Another one is that, so our department, EGLE, has approached the US EPA. Josh mentioned that some of the early work looked at toxin production or the genetic ability for the stuff to produce toxins. We only have one sample that the Army Corps took during their study that demonstrated some really minor amounts of toxins that were found in the water column, but it was a one-time sample, and that doesn't help us a whole lot. And so we have now approached the US EPA, and they've, I'll say, all but committed to funding. We're real close on this, to funding a pretty extensive toxin study that'll happen in 2027 to look at toxin production, the potential for it at these 5 locations along the lakeshore. And this isn't just a one-time grab. This will be monthly samples, multiple stations, multiple scenarios to try to understand the potential for the stuff to produce any kind of toxins. Because obviously, if we're going to talk about removal, if we're talking about citizens doing removal or contractors doing removal, knowing whether we should be concerned with any kind of human health impacts is going to be an important thing too. So this will hopefully get at some of that answer as well. So that's coming down the pike in 2027. And then actually Josh and I put forth an internal request for our own monitoring within EGLE that we're going to be doing this summer to look at some of the nutrient components of this. So one of the real quandaries has always been like, why is this only showing up really in L'Anse Creuse? Because everybody says, is it happening elsewhere? Is it happening on the Ontario side? And we really don't see this and haven't heard of this kind of issue elsewhere. And so the question is, then why is it where it is and what's driving that? A lot of the assumptions are that it's probably potentially nutrient-based. Again, it lives on the sediments, does a really good job of pulling its nutrients out of the sediments, not necessarily out of the water column. And so the theory could be that it's sitting essentially in kind of the plume from Clinton River, right? Like where it comes out here. And so that's a very likely thing, but without testing it, that's all it becomes is kind of a guess. So the plan this year and that we came up with was to at least test some of that. So this is going to be doing sediment sampling both within L'Anse Creuse Bay and also Anchor Bay, where the question mark is. Going out there, taking sediment samples for nutrients, sediment grain size to see if the particle size is different, and also taking out, the plan is hopefully to do an underwater camera too, just to document for sure that we know where it is. We haven't done any work up in Anchor Bay that I'm aware of. So also going to kind of take observations to at least test that water to see if what we see are different nutrient concentrations where it is growing versus where it's not. And that'll at least either help provide some confirmation that yes, this makes sense, it's within that plume. Or if it doesn't, then it's another kind of head scratcher, but another piece of the puzzle trying to figure out why it is where it is. So that will happen this summer. I expect Josh and I will be out cruising Lake St. Clair ourselves. That's my hope. So we've got these kind of three components coming up. This will not be the end of this story because I think you can all appreciate this. It's a bit, if you've seen it, if you've dealt with it, this is a big issue, and it's an issue that's been around for quite some time. There's a lot of debate about why. I think pointing to these wholesale ecological shifts, massive clarity of the water after the zebra and quagga mussels, which means it's got a lot more habitat to grow, could be a part of it. And then some of these, maybe it's these legacy nutrients too, that are issues in the sediment might be some of the drivers, but trying to get at some of those whys and then work on some attempts to clear it out and trying to learn how and when it comes back and where. And we'll take those steps and then figure out what the next steps are after that. So that's where we are. That's who we are. And if you have any questions, glad to answer them.
Do you know yet if there's any nutritional value in this, if you took it out and put it on your garden? You mentioned nitrogen, I think.
Yeah, I mean, I don't know. I don't know. I do know this stuff. The thing that's interesting about it is that if you've never seen it, it doesn't break down very well. I mean, there's a reason that it stacks up like the pictures that Josh shows. It's a really different, the sheath that it builds along those filaments is a really rigorous sheath. So it persists a long time. So I don't even know how well it would break down in soils over time or things like that. And I will say, like from a gardening standpoint, we get this question a lot with any kind of place that has cyanobacteria and potentially cyanotoxins, is that a wise thing to pull something out that may or may not be producing toxins and throw it on something that, now most of the cyanotoxins will break down pretty quickly in sunlight and things like that. But I don't know. And to be honest, the mass of this, I mean, on an individual level in the backyard, I don't know, maybe, but it won't make a dent. I mean, the real question is, if we can pull this stuff out in mass, if that's part of the solution is just sort of a continual harvest protocol, where does it go and how do you haul it? And to Josh's point about, I mean, the big issue with this is going to be if we have to pull it out and move it, I expect a ton of the expense will not just be in the removal, but will be in the hauling, just because of that. Unless we can find a place to drain it and dry it and let it do that before you can haul it, the volume is pretty atrocious.
I was thinking sod farms, if it has some nutritional value as fertilizer, maybe the sod farms would be glad to put it out over their acreage.
Yeah, I don't know how well it would incorporate. Yeah, I don't know. I mean, because it stays pretty, those balls stay like that, even if they dry up, they blow around like little marbles. They're crazy.
Okay, another question is, do you know of any impact that it has on the egg hatchery? And talk about the spawning and all.
But I mean, part of the discussions about like what to do in the future with this is has this been a replacement for things like our natural macrophage, natural plant growth density and diversity? Has this kind of like masked some of that? Are we getting to like monocultures that could affect who knows what? But no, I haven't seen anything that talks about impacts on that sort of thing. But I mean, certainly as big an area as that is, again, at least 1.5 miles offshore through that whole stretch. It's a lot of coverage.
Hi, so we help we work with the Clinton River Watershed Council during their river days. And I believe it was last May that we found in our section, which is the Cottrell Drain, that we found this in there. And we were told by Clinton River Watershed Council that it's the first time that it's been found in that. So it's moving inland. You're right, it was a very, very dense, heavy, thick mat. But the thing that I found really, really interesting in it, we were finding we're in there looking for water bugs and examining which ones are in there. We found very few until that came up, and that's where we found the majority of them. So I wondered if you guys had any kind of insight, like, is it a healthier habitat in some respects? And what you just said about it being possible replacement for the natural vegetation, that kind of connected that to me.
Yeah, can you repeat, sorry, what was the drain that you mentioned it was found?
Cottrell Drain,
Okay.
for the Clinton River Watershed Council is called LSC4,
Okay.
their
Yeah.
site number.
So I do know that when the Army Corps first came in that 2023 sampling, we did have that initial question, not only is the Clinton River supplying nutrients for this, but was it actually found up in the Clinton River watershed itself? And so they went up through the spillway and did a couple of grabs to look for this Microceria woolii in the spillway, and they did not detect it there. So if what you're saying is the case, then it would, to my knowledge, be the first detection of the species in the Clinton River watershed itself, outside of Lake St. Clair proper. As for the habitat component of your question, where you're saying that's where we found the most aquatic insects and whatnot, it's possible, depending on the previous habitat available in that drain, that maybe Microceria coming in was the most optimal habitat that they've seen in a while. I don't know without seeing what the conditions in that drain were prior, but whether it's a better habitat than native vegetation, I think it's hard to say.
Right. Okay. I was just really curious about that.
There are a couple questions online. One is, what is the suspected cause of this growth?
Yeah, that's kind of the, $800,000 question, if you will. The suspected cause, it's unclear at this time, but again, we're trying to connect those dots, and it's believed to be some kind of combination of, major ecosystem change related to some of those invasives coming in, particularly the dry-scented mussels, clearing up the water clarity. And as I had mentioned earlier, it can tolerate lower light conditions than a lot of other aquatic plants. So it might just be the case that when this water cleared up ever so slightly even, the Microceria is the first organism that's able to exploit that new habitat. It could be that as a factor, and it could also be, like Kevin had mentioned, some of these legacy nutrients that have been building up in those sediments for a while, and it's just the first thing that's able to see that and exploit that. But the overall cause is still unclear.
Okay, thank you. And then another question is, will there be any opportunities this summer to assist with the project?
Yeah, that's a good question.
So well, I guess it depends on which project. So I would say from like the $800,000 side, probably not, because that's going to be a contractor run, professionals doing that work. From our project, the sediment sampling work that we're doing, I expect it won't be a ton of field work, but we'll be out on the lake, and we haven't even started talking about what that looks like yet, because I think we just literally this past week decided that this would be a go within the confines of priorities and things like that for the year. So to be determined still.
And if people are interested, should they reach out to you, Kevin, or Josh?
Either. Yeah.
Either one?
Either one of us. Yeah. Yep.
Okay, thank
Right.
you.
I guess I had a question and just a comment on the habitat question earlier. I wanted to mention that with our nearshore pike net survey, we surveyed some of the areas with the mats. And oftentimes some of those areas were where we saw some of our higher fish catch rates. But also the first year we did the survey in 2021, we didn't catch very many turtles, but then this year we caught a lot of turtles, and in those mat areas is some of our higher catch rates for turtles as well. So just kind of an anecdote from that survey. But the one question I had was, are you seeing these on the Canadian side as well?
No indication that we've heard yet. No, we've been talking to some of the Canadian partners and the folks who work kind of on Great Lakes issues in general to see, if this is something, again, unique to like this one portion, and if so, why?
I was just curious with
right.
predominant winds going
Right.
that way, but
Right. Yeah. Part of the other issue, I think, if it is, would be interesting, the habitat stuff that you talked about, that hardened shoreline versus naturalized shoreline. We said this is the kind of thing that if it was more naturalized shoreline, you may not even notice it in some places, right? It might go in and actually might get incorporated. And, a lot of that growth that Josh was showing, that kind of, again, if that was part of a more naturalized shoreline, it may just blend right in and ultimately get incorporated. But I think that the extensive hardened shoreline on Lake St. Clair side on the US side puts it right in your face.
Great, thank you. And there is another hand raised. Brian, I see your hand is raised. If you want to unmute to ask your question.
Yes, I think if you can hear me.
Yes, we can.
Sort of a commentary on this issue with the muck issue, as they call it. It seems to be fallout from the Clinton River, the spillway. The L'Anse Creuse Bay area has always been known as sort of a dead bay. So, in shallow water, temperature is obviously going to be much higher. So I think it's probably going to lead to a multifactorial type cause. And the Army Corps of Engineers might be our best help. So it's just my thought.
Yeah, I think that's absolutely right, and that there's probably multiple factors driving this issue. It's not sort of a silver bullet kind of a situation. And I agree. It was really cool to see the Army Corps come in. Anytime you can collaborate with several agencies on an issue and come together and put all your best minds together, it's a cool thing to see. And not to mention their really sweet, awesome technology that they had.
Thanks.
Yep.
Awesome. Well, thank you all so much for joining us tonight. Just in an effort to get you out at the promised time, I'm going to cut us off for now, but feel free to follow up with our speakers if you have other questions. Their contact information is at the end of the slides. And we also have some recordings that will be made available. Again, thank you so much. Thank you to our speakers again. This wouldn't be possible without you guys, so really appreciate you. And with that, have a good day, everyone.